For our last learning target, we've got problem 64, and similar to the problems that we've done before, we should know now that we have to leave the absolute value expression alone, subtract 10 from both sides, and by doing that, we still have that 1 over 11 multiplied by this absolute value expression, but the 10's canceled, so we get less than or equal to 11 minus 10. Remember, just because you have a minus sign there doesn't mean you change the direction. You only change the direction of the inequality symbol if you multiply or divide by a negative number, not if you subtract something. So we're going to go ahead and 11 minus 10, we're going to simplify that and write 1. Now, we have something times this absolute value expression, and we want to get rid of that number that's on the outside, and the way we get rid of 1/11th is by multiplying by 11 over 1. So 11 over 1 is the same as 11, so the 11's cancel, and we get the absolute value of 2x minus 4 is less than or equal to 11. So now we have another inequality here where we have the absolute value bars by themselves. Now we can write this using a little bit of logic here, and let me draw a picture of that because sometimes pictures are a lot easier to kind of understand. So we have 0 here, we have 11 here, and we have negative 11 there. This statement says, and I urge you to pause the video and see if you can finish my sentence. This statement says, pause the video now, this statement says that 2x minus 4 has to be less than or equal to 11 units from 0. So if we look at that graphically, it's kind of like having a boundary. You have a leash on your dog, and the leash is tied right here, and it can't go further than 11 units that way, and it could go all the way to 11, so we'll use a bracket, and it can't go further than, it can go up to and equal to, but not further than 11 units to the left. Now, what can't go more than 11 to the right or to the left? Well, it's the 2x minus 4 that can't go more than that number to the right or left, more than 11. So we want to kind of squeeze or sandwich in the 2x minus 4 in between less than or equal to 11, but greater than or equal to negative 11. So going from this step here to this step here is a big deal. Notice there's no more absolute value bars here. Now we just have a compound sentence that we can, statement that we can easily solve by adding 4. When you add 4 to the middle, because we still want to get x by itself, when you add 4 to the middle to get rid of the 4's, to get rid of the negative 4, we have to add 4 to the right side. But we also have to add 4 to this one. So basically we're treating this like 2 equations in one. And when you add 4 to the negative 4, that cancels out. Negative 4 and positive 4 equals 0. 11 plus 4 is 15. And then we keep the inequality symbols in the same position. And then negative 11 plus 4, that's negative 7. Just like if you had 2x equals 15, you would divide both sides by 2. But you have this other one over here, so you want to also divide it by 2 and solve everything together. It's the easiest way to do this, guys. So if we divide both sides, or all 3 parts by 2, the 2's cancel here, and we get x is less than 15 halves. And let's write that as 7.5. And then x is also greater than or equal to negative 7 halves. That's negative 3.5. I think it's easier when you need to graph to write it as a decimal. That way you can easily find what you're looking for on the number line. So the number x represents the real numbers x that are in between 7.5, and I'll put 0 over here, and then I'll put negative 3.5 right there. So our real numbers that make the original statement true are the real numbers in between and including negative 3.5 and 7.5. And that's it.